After we learned the continuity, we're going to learn this called intermediate value theorem. What it says is this. We have a function. Okay, here's A and here's B. If this function is continuous on the interval a comma b, you look, it's a closed interval. And here is f of a, right? And of course this here is f of b. And I want to make sure that f of a is not the same as f of b. That means they're not at the same height. So there's some difference there. Then the intermediate value theorem says for any point for any value, let's say k, it's between fa and fb, then there got to be at least a point in the interval or between a and b, c, to make f of c equals k. So what it says is this. Here's fa, here's fb, and I just give any number or any value between fa and fb. So if you put a horizontal line here, then your graph has to go across this or has to meet that. Where it's going to get across could be here, or at least one point, because sometimes if I give you another function very similar, but it might have something looks like this. So for this given k, you have 1 point, 2 point, and almost a 3 point. Yeah, you have 3 points. But the intermediate theory just say at least 1. So at least 1. As long as you get 1, that'll be good enough. When we talk about the continuous function, which means if you use your pen to go with the curve, you don't have to lift the pen, which means you have to go across. Yeah, if you want to go from here to this point, you have to go across this horizontal line somewhere. That's what it says. Okay, a very special case is this. If you remember that when we learned in pre-calculus, we also call this intermediate value theorem. And what it says is this. If f of x is a continuous function, it's a continuous function. Okay, and if we have f of a and f of b have opposite signs, what does that mean? That means one positive, another one negative, right? Then there is at least one number c in the interval a and b such that f of c equals 0. And that means, in another word, if you have f of a and f of b, they have opposite sign. One is positive and one negative, then there must be at least one 0 between a and b. Make sense? Because f of c equals 0, then c is called the 0, one of the zeros. So it could be more than one. So c is a 0 of this function. So there is at least 1 0 in this interval. This is a special case of this general form. All right. How do we use this? How do we use that? Sometimes you're given a function, f of x is given, okay? But it's very complicated. I don't want to write it. It's very complicated. And I want you to find a solution for this equation, f of x equals 0. You know how the computer would do that? or calculator or something would do that? We don't know. If I give you a very complicated function, it's really hard to find where that solution is. You graph it? Yes, you can graph that, and then you're going to find something looks like, well, it's weird, right? All right, now how do you find the solution? Here's the tricky part. You find a number, A, you find another number B. If f of A is a positive and f of B is negative, then there must be at least one zero between A and B, isn't it? So let's see, f of A is positive, or we say greater than 0, and f of B is less than 0. So we get an interval here, A, remember, positive, B, negative, okay? So that's a function value. So what you're going to do is you take the midpoint here. And what is this midpoint? Is A plus B over 2. And then to find f of that, f of this midpoint, if the f value, the function value at this midpoint is a positive, then you shrink your searching interval to half of what it used to be. So there must be one solution right here. And then you go to find another midpoint. Okay? And keep doing that. If your f of A plus B over 2 is negative, here positive, then there must be one solution in between this A and A plus B over 2. So that's a general idea. You just do this many times, repeat until you get an answer. But this number at the end, you get this number, it might be like, I just made this up, might be 3.8596483 or something, or maybe it stopped somewhere there. So how do you get this number this accurate? We do need some accurate solutions sometimes. How do you get that? Use this method, okay? So you probably will find like somewhere between 3 and 4, and one between the x equals to 3 and 4, the function has a different sign, the function value has a different sign, and then you, between 3 and 4, then you get a 3.5. So you find 3.5 has opposite sign with a 4, so there's a solution between 3.5 and a 4. Then you pick the midpoint, 3.75. So you just keep doing this. This is how you use this. If you like to do the computer programming, then you can write a program and to do this, do a lot of if-then sentences. The computer can find the solution for you easily. Okay, so I think that's about it. I need to know this method, cutting half, is called a bisection method. That's how the calculator or the computer people will do that. All right, so you can, I think so far we're okay, because this is really not a hard to understand theorem, the intermediate value theorem. Okay, this is a short one.